Hi, it's Miss House. I want to talk with you about the difference between a secant line and a tangent line and why this is so important in calculus. I want to do that by showing you a couple of graphs. So f of x equals x squared plus 2x. This is the graph of a parabola, and you can see it has x-intercepts at -2 and at 0, and here its vertex is down here at -1, -1. Now, a secant line to this graph would be through any 2 points on the graph. So if I pick a couple of points, like let's see what happens at -3. So let me open up something I can write on here. So remember, it's f of x is x squared plus 2x. I'm going to pick x to be -3. So look, f of -3 would be -3 squared plus 2 times -3. That would be 9 minus 6 is 3. So that puts a point on this graph at -3, 3. Oops. Okay, so see here at -3, it's at +3. Okay, now I'm going to pick another point. Let's say I pick 0, because that's an easy one. So I do f of 0. That's going to be 0 squared plus times 0. Well, that's going to be the point 0, 0. So on my graph, I'm going to label and graph 0, 0. And by the way, this program is called Desmos, D-E-S-M-O-S. It's completely free, and if you need to visualize something, this is a great site to go to. Now, if I were to draw a line through these 2 points, okay, that line would have a slope or a slant, just like all lines have. That would be the slope of the secant line. So let's create the line, the equation of the line, so we can graph that. So what do I have? I have these 2 points. I have -3, 3. We'll call that point 1. And I have 0, 0. We'll call that point 2. And I'm trying to write the equation of the line, of the secant line, through these 2 points. Now, you know how we find the equation of a line is we have to find its slope first. So remember what the slope formula is. y2 minus y1 over x2 minus x1. Okay? Now, the difference between algebra and calculus, and this is the algebra form, the formula of the slope, but in calculus we use function notation. So if we have a point A, f of A, that's my first x and my first y, and the point B, f of B, that's my second x and my second y. So we write our slope formula in a slightly different notation, but it's exactly the same. It means the same thing. We write it f of b minus f of a over b minus a. So the slope of this line that we're working with would be the second y, 0 minus 3, over 0 minus -3. So that slope would be -3 divided by 3, which is -1. And if you look at the graph, every time, now I don't have the line here yet, but to get on the line that I'm going to draw, I would go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. I still don't have the equation though, and I need to write the equation of that line. Okay, I found my slope, and now I need to write the equation of the line. Now there are two ways to do that. Okay, and you can use either of the formulas. I'm going to move my slope up here. Okay, the two formulas are y equals mx plus b, or y minus y sub 1 is m times x minus x sub 1. Now, regardless of the formula you use, you have to solve it for y, right? In order to put it into this grapher here, I have to put y equals, or f of x equals. It's the same thing. Remember, y and f of x are the same thing. So I'm going to use the first formula, y equals mx plus b. Okay. Now, I know that my slope is -1, and x and a y here, and an x and a y here. And I can use either one. And I'm going to use the easiest one, which is 0, 0. So I'm going to write 0 equals -1 times 0 plus b, because look, this is y. Look, I'm using this y right here. Equals m, this is the m that we found right here, x, here's the x I'm using right here, plus b, and look, that's 0 equals b. So y equals -1x plus 0, and of course we can write that much more efficiently and cleanly as just saying y equals -x. So I'll write y equals -x. So that's the equation of my secant line, y equals -x. And look how that line goes through those 2 points exactly. The slope is -1, so it's down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. Okay? So anytime we're looking for the change between 2 points, we find the slope of the secant line. That's between 2 points. Look, this is how the curve changed from -3 to 0. And that's the average change, because look, it doesn't always have a slope of -1. Look, this is much steeper than -1, and over here it's got a slope that's positive. But this is the average rate of change, and it turns out to be -1. That's the slope of the secant line through those 2 points. But if I want the slope at this very specific point, that's called the slope of the tangent, and we have a different formula for that. Now, you need to think about the difference between the change in a secant line and the change at a specific point, the tangent line. So here is a sort of informal real-world application of this. Think about this for a minute. Let's say you're driving between 2 cities, and you drive at an average rate of 60 miles per hour. So your change is an average of 60 miles per hour. But let's say that at one point you're going 75 miles per hour, and a state trooper puts the radar on you at an instant, and you're going 75 miles per hour. So even though you only averaged 65 miles per hour or 60 miles per hour, at that instant you were going 75 miles per hour. That's the slope of the tangent. That is the change at an instant, okay? So if I want to know the change at the point -3, see right here, not between these 2 points, but exactly at, then I have to use the definition of the derivative, okay? That's called the derivative, by the way, the instantaneous rate of change, okay? So our regular slope formula, f of b minus f of a over b minus a, that's y2 minus y1 over x2 minus x1. That's the average rate of change. So when we look at our graph, we can see that I'm looking at this red curve, that sometimes it has a negative slope, sometimes it has a positive slope. Here it has a really steep slope, and here's not quite as steep, but its average rate of change between these 2 points we found to be -1, right? So if you go down by 1 to the right 1, down by 1 to the right 1, down by 1 to the right 1, do that over and over, you end up at this second point. That's the average rate of change when it is between 2 points on the curve. Now we're looking to find it at an instant, okay, at a specific point. So we need a new formula, and we're going to say our points are at x and x plus h, okay? Now, this point is at f of x, that is the y value at x, and this point is at f of x plus h. We moved over h units, okay? Now, think about the slope. The slope is the second y. This is our second y. So it's f of x plus h minus our first y, f of x, okay? Our second x was at x plus h, and we got to minus our first x, which was x. So we have a numerator of f of x plus h minus f of x, and down here the x's cancel out, so it's over h. This is called the difference quotient, and you may have seen that before. You should have. Now again, it is the slope formula exactly, okay? But look at the difference here. We were able to simplify this and get just an h. Well, that's the distance between these two, and that's the same as the slope formula. This is still a secant line, okay? This is still a secant line because we're between this point and this point. Okay. What makes this different is we're going to add a limit to this. The limit as h goes to 0 of f of x plus h minus f of x divided by h. This is the slope of the tangent. Okay, now why is this the slope of the tangent? Let's go back to our graph. Let me snip this graph. Okay, so here's our graph. And remember, we found the slope of the secant between 2 points. And now we have a new formula for the slope of the tangent, and I want to know the formula right here. So think about what we did. We called this x and this x plus h. The distance between them we said is h. So what we want to do is we want to move this point, the second point right here, instead of being h units away, we want to move it back toward this other point until the distance is 0. That's the limit as h goes to 0. So what we're doing is we're taking our second point and we're moving it back until it's at that exact point. And if we do that, we'll be finding the instantaneous rate of change. All right, so let's do that for our function that we had. our function was f of x equals x squared plus 2x. Now what we have to do is f of x plus h. Okay, so that's going to be x plus h squared plus 2 times x plus h. Now, if it's been a while since you've taken algebra, x plus h squared means x plus h times x plus h. That's x squared plus xh plus xh plus h squared. And these can be xh or hx. xh is just typical. It's x squared plus 2xh plus h squared. It is not x squared plus h squared. So this is x squared plus 2xh plus h squared plus 2x plus 2h. Now that's just f of x plus h. From that, we're supposed to subtract f of x. So I'm supposed to subtract every term that's in the original. So I've got to subtract an x squared, and I've got to subtract a 2x. And if I do that, look, the x squares and the 2x reduce to 0, and every term that's left has an h factor in it. 2xh plus h squared plus 2h. Now, the last step in the formula says divide it by h and then take the limit. So let's divide everything by h first. And this h is a common denominator. Okay, so we're dividing by h, and that gives us 2x plus h plus 2. And the last step is to take the limit as h goes to 0 of 2x plus h plus 2. And look, if h goes to 0, if substitution is possible and it doesn't cause something to be undefined or unable to simplify, you just plug in that 0, it's 2x plus 2. And this is the formula for the slope of the tangent. And that's anywhere on the curve. Okay? This is for any x. Now, in my example, we had said, right, that we were going to find it at -3. So our x is -3. So we're going to use our formula for the slope to find the slope of that line at -3. Okay, so create a little space here. This is our formula for our slope. So we know that slope is 2x plus 2. We found that using the limit definition of a derivative. We want to know the slope when x is -3. So our slope is 2 times -3 plus 2 is -6 plus 2 is -4. Okay? And our point is -3, 3. And so to write the equation of that tangent line, y equals mx plus b, 3 equals -4 times -3 plus b. So doing the arithmetic and solving for b, 3 equals 12 plus b, negative 9 equals b. Subtract 12 from both sides. So now we know the equation of the line, that is our tangent to the curve at that point, is negative 4x minus 9. This is the equation of the tangent at x equals negative 3. Negative 4x minus 9. So we found the equation of our tangent line by using the slope we found using the limited difference quotient, and the point, we plugged it in and we got an equation. So look, that's our secant line. Let's put in our tangent line. Y equals negative 4x minus 9. Look, that's the tangent to the curve at negative 3, 3. There it is right there. Look, notice how the secant line goes through 2 points and the tangent line goes through 1 point.